Okay, good afternoon. This is Tutor Wambinji. We look at calculus. Okay, so calculus is just a simple topic in mathematics. It's just a branch of mathematics that deals with two important things, and that is differentiation and integration. So there are only two things that are important in calculus. Okay, so the first thing, we start with differentiation. So differentiation, for you to understand differentiation, we just have to look at what is involved in differentiation. So in differentiation, there's only one thing that is involved, and the thing is what we call the dy dx. So this dy dx is called, it is also called the derivative. Okay? It is also called the derivative. You can call it derivative, you can call it dy dx, or you can call it gradient function. So if you find any question that simply talks about dy dx, well, what you have to understand is they are talking about derivative. Or if the question is simply talking about derivative, not to say they want dy dx. If the question is about gradient function, not to say what they want dy dx. Examples. Okay, so example 1 says, find the dy dx of the following equations. Find the dy dx of the following equations. If I want, I can remove dy dx and put what? Find the derivative, because derivative is the same as dy dx, which is the same as the gradient function. So example 1, the question is y equals 4x squared. We find the dy dx. So dy dx means we have to look at the change in y with respect to x. So how do you find the dy dx? The only thing that is involved here is we are just using two operations. The first operation is times, and the second operation is minus 1. So you get this power, you bring it down here. You say 2, the power 2, bring it 2 times 4, this 4. Okay, x. Then 2 minus 1. So we are just doing what? Times minus 1. Times minus 1. So times the power times this. Then you subtract a 1 here. So 2 minus 1 is a 1. So there's a 1 here. So dy dx is 8x. We are done. Okay, B. Find the dy dx of this again. So what we do here is we have to look at dy dx equals power. We start with times. Times 4 times 2 is 8. Then you remove a 1 here from the 4. We remember we are using it times and minus 1. Times minus 1. Times take away 1. Times take away 1. So it's times take. Times take. So 4 times 2, 8. 4 minus 1, 3. You come here. 2 times 3, 6. This 2 minus 1 is 1 here. Then this one is, there's a 1 here. 1 times 2 is a 2. Then this 1 minus 1 is a 0. Any number to the power 0, any letter to the power 0 is what? Is 1. Then the dy dx of a number without a letter is always 0. So here there's a 0. You just leave it out. So the answer for the dy dx for this is 8x cubed minus 6x plus 2. Okay? That is example B. Example C. Find the dy dx of y equals 6. There's no letter here, there's no variable here. So the dy dx here, x here, we assume x is there, but the power is 0. Because any number to the power 0, any letter to the power 0 is 1. So y equals 6, x to the power 0. 0 times 6, you get a 0. So the dy dx of any number without a variable is always 0. D. Find the dy dx of y equals x minus 1. So the power here is what? 1. You bring the 1 here, 1 times x, you get x. 1 times x. Then that 1 there, you say 1. There's a 1 here. Then you say minus 1. 1 times x. 1 minus 1, you get a 0. So this will be y equals x, okay, to the power 0 now. And x to the power 0 is what? 1. That is the 1 here. Okay, so dy dx of this is just 1. This one, there is no letter here, it's just a 0. Okay? Then we come to E. Find the dy dx of this. Here now, you have two things. You have the numerator and the denominator. So with this denominator, what it means is you can simply take this denominator on top. That is my second step. When this x goes on top, it is going to have the power of negative 1. Here the power is positive 1. When it comes on top, you change this sign of positive to negative to have a negative 1. Then you distribute this. Okay, you expand. X to the power negative 1 times 4x. You get what? 4. Why? Because here there is a power of positive 1. When you are multiplying a number or letters of the same base, you add the powers. So negative 1 plus positive 1, you get a 0. X to the power 0 is 1. See that? Then you come here again. You say negative x to the power negative 1 times positive 1. You get what? Positive x to the power negative 1. You understand? Then again we do the same thing. The times and take away. Times and take away. Here there's no letter. Automatically the dy dx of 4 is 0. So you ignore, throw this away because there's no letter here. Then you come here. You drop the power negative 1 times negative x, you're going to have negative x. Negative 1 minus this 1, you get negative 2. Then, now that our power is a negative, we can change it to positive. This negative, it means there's a 1 here. Okay? That is a negative 1. Then this x, you bring it down, then you change the sign of the power to be now positive. So the dy dx here is negative 1 over x to the power 2. Okay, that is done. So unless you have a question, so that marks the simple basics of differentiation. So when we are differentiating, in short, when you have an expression like y equals ax to the power n, like that. So what is there is, for you to find the dy dx, you drop this, it comes down to be n times ax, and then you take away 1 from this. Okay, that is the formula we are using here for you to understand this differentiation. Thank you very much. That marks the simple explanation about differentiation. There's nothing that is more than that. Okay.